Lesson 97, Part 1. You know how to change fractions into mixed numbers. You're going to learn how to change mixed numbers into fractions. Read this number. This number is read as 3 2/5. We're going to complete the equation to show the fraction that equals 3 2/5. The first thing we do is change the whole number into a fraction that has the denominator of the fraction. The denominator of this fraction is fifths. So we write 3 as a fraction with a denominator of 5, like so. The numerator is 3 times the denominator. What's 3 times 5? 3 times 5 is 15. That gives us our numerator. Let me repeat that. The numerator, that goes right here, is 3 times the denominator. It's 3 times because the number 3 is our whole number. So 3 times 5, these two, equals 15. Now we're going to add 2/5 to 15/5, giving us 17/5. What fraction equals 3 2/5? 17/5 equals 3 2/5. We're going to complete the equation to show the fraction that equals 7 1/3 now. What will this fraction equal? That goes right here, 7 1/3. Our denominator is 3. The numerator that we're creating is going to be 7 times 3, giving us 21. Now we have 21/3, which represents our 7, adding it to 1/3, giving us 22/3. One more. 5 2/9. We'll change 5 2/9 into a fraction. Our denominator for 5 needs to be the same as the fraction we already have, 9ths. Our numerator for the 5 is going to be 5 times the denominator. 5 times 9 equals 45, giving 5 the fraction of 45/9. Then we're going to add it to 2/9, the fraction we already have. Altogether, we have 47/9. Now we know 5 2/9 equals 47/9. Now please open your workbook to lesson 97 and find part 1. Pause the video now to get there. Lesson 97, part 1. Problem A, the mixed number is 3 7/10. Below the mixed number, you'll write the fraction, addition, and then complete the equation. So below, you will have the mixed number, you'll write the fraction addition, and then complete the equation. First, you write the fraction that equals 3. The denominator for that fraction is going to be 10, just like the one you already have. The fraction that equals 3 is 3 times the denominator, which is 10, giving us 30/10. Then you'll add that to the existing fraction, 7/10. Altogether, 37/10. Like so. Work problem B on your own. Pause the video and continue when you're ready to check your work. Problem B says 2 5/8. you're going to turn 2 into a fraction to add it to 5/8. The denominator needs to stay the same as the one you already have. So 2 needs to turn into a denominator of 8 with a numerator which is 2 times greater than your denominator. So 2 times 8 equals 16. Here's your work. Now, let's move on to balance beams. You're going to work a new kind of balance beam problem. This number line starts at 0 and goes to 12. We want to find out where the balance point would be for those weights. The balance point is the average distance. Picture our balance beam triangle right here on 0. So we now know the right-hand side. The left-hand side is still a mystery. So find the average for this side. So we'll find the total distance from 0. Then we divide by the number of weights to find the average distance. So we have 3 1s, 1 4, 3 6s, 2 10s. And how many weights do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 weights. Remember, first we find the total distance from 0, then we divide by the number of weights to find the average. If we put the balance point at 4, it won't balance. So our balance triangle that goes here on the 0, imagine it sitting right now on the 4. Which side would be heavier, the left or the right? Picture this. The right side would be heavier if we put the balance on 4. We have 3 on 6 and 2 on 10. Here we only have 3 on 1. Now, if we put the balance point at 9, will it balance? Moving this over here. No, it still won't balance if we put the balance at 9. Now the left side is too heavy. We have 3 on 1, 1 on 4, 3 on 6, and on the right side we only have 2 on 10. We'll find the average distance. At the average distance, we have the same distance on both sides. The total distance at 1 is 3. We have 3 weights there. The total distance at 4 is 4. So 1 plus 1 plus 1 is 3. 4 by itself is 4. What would our total distance at 6 be? It would be 6 plus 6 plus 6, or 6 times 3, giving us 18. And our total distance at 10 is 10 plus 10, giving us 20. Here's the total at each spot where there's a weight. We add the totals to find the total distance for all the weights. Find the total distance in part A. Add these up. When you add these 4 numbers together, you should have 45. 3 plus 4 plus 18 plus 20 is 45. Now divide by the number of weights to find the average. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 weights. So now divide 45 by 9. The answer is 5. So the balance point for these weights would be at 5. Now it's balanced on both sides. Let's check to see if the total distance is the same on each side of the balance point. These weights are 4 units from the balance point. This weight is 1 unit from the balance point. Takes 1 hop to get over to 5. This takes 1, 2, 3, 4. So 4 and 1, giving us, that's right, 5. Now, how many spots does it take us over here? 1, 2, 3, 4, 5, and 1. So this is 4 units away from the balance point, giving us 3 weights. The total distance for these weights is 12. How many units is this one away from the balance point? 1. It's 1 away. How many units are these weights from the balance point? 1. How many weights are there? 3. And 10. How many units are these weights away from the balance point? 1, 2, 3, 4, 5. How many weights are there? 2. So 5 times 2, 10. So our total distance on this side, 12 plus 1, is 13. And our total distance on this side is 3 plus 10, giving us 13 as well. That's how we check to see if it's balanced. So the correct balance point is 5. We have the same total distance on each side. Now let's switch gears into probability. You're going to work problems that tell about taking trials. Whenever you take trials by pulling things from a bag, here's what you do. Step 1. You reach into the bag without looking. Step 2. You pull out one thing. Step 3. You record what that thing is. Step 4. You return that thing to the bag and shake the bag. Then you're ready for the next trial. Again, let's repeat. For taking trials, you have 4 steps. Step 1, you reach into the bag without looking. Step 2, you pull out one thing. Step 3, you record what that thing is. And step 4, you return that thing to the bag and shake the bag. The reason you want to shake the bag before beginning the next trial is so that you don't know where things are in the bag. You can use probability fractions to estimate how often you'll pull out objects of a particular type. If the probability fraction is 2 out of 3, or 2/3, you expect to pull out that type of object on about 2/3 of the trials. If the probability fraction is 1/2, you'd expect to pull out that type of object on about 1/2 of the trials. The fraction seen here shows the probability of pulling a white marble from a bag. On 3/8 of the trials, you'd expect to pull a white marble from the bag. If you took 8 trials, you would expect to pull out a white marble on 3 trials. Let me repeat that. The fraction shows the probability of pulling a white marble from a bag. On 3/8 of the trials, you'd expect to pull a white marble from the bag. If you took 8 trials, you would expect to pull out a white marble on 3 of those trials. If you took 16 trials, you would expect to pull out a white marble on 6 trials. How many white marbles would you expect to pull from the bag after 8 trials? You'd expect to pull a white marble 3 of those trials. How many white marbles would you expect to pull from the bag after 16 trials? You'd expect to pull 6 white marbles after 16 trials. If you took 24 trials, how many white marbles would you expect to pull from the bag? You would expect to pull 9 white marbles if you took 24 trials. We can write equations that show probabilities. The equation for this problem is 3/8 t equals W. T stands for trials and W stands for white. So this equation says 3/8 t equals W. 3/8 t equals W. T stands for trials, W stands for white. The equation tells you that for 3/8 of the trials, you'd expect to pull out a white marble. Again, for 3/8 of the trials, you'd expect to pull out a white marble. This equation is read 1/9 t equals W. This equation tells about the probability of pulling out white marbles from a different bag. For 1/9 of the trials, you'd expect to pull out a white marble. This letter T tells about trials. This letter W tells about white marbles. What fraction of trials would you expect to pull out a white marble in this equation? 1/9. These are probability fractions for pulling out white marbles. Probability fraction A, 3/10. So for 3/10 of the trials, you'd expect to pull out a white marble. So the equation for trials is 3/10 t equals W. Fraction B, 3/17. So the fraction for pulling out a white marble would be 3/7 t equals W. Fraction C, 2/5 of the trials you would pull out a white marble. Fraction D, 10/23 of the trials you'd pull out a white marble. Open your textbook to lesson 97 and find part 1. You're going to write the equation for trials. For all of these pictures, the probability fraction will tell about white marbles. Picture A, write the probability fraction for picture A. The probability fraction for pulling out a white marble is 3/7. The equation would be 3/7 t equals W. Equation B, 4/9 t equals W. Fractions, pause the video now to work the other C and D. Resume when you're ready to check your work. Problem C, 2/7 t equals W. And problem D, 4/5 t equals W. That concludes part 1 of lesson 97. Continue on to video part 2.